2.12, rationalize binomial denominators. Last lesson was monomial. Now we're talking about binomials again, which means there's two terms in the bottom. So you'll see a plus or a minus sign between two terms. So here it is again saying it's a polynomial with two terms. The plus or the minus between them is how you know there's two terms. To get rid of a binomial with a radical, you multiply by what's called the conjugate. So remember this word, the conjugate is just a fancy way of saying to change the plus or minus sign in the middle of the terms. So number one, remember we talked about how you cannot have a radical in the denominator. It cannot stay there. So we have to fix how this answer looks by multiplying by something. And we need that something to really equal 1. And that something is going to be the same denominator but change the sign between the terms. So we'll take it times 7 minus square root of 14 over 7 minus square root of 14. And so see how these are exactly the same thing. They are really secretly 1. And because we're dealing with binomials now, I'm going to put parentheses around every binomial. So on the top, we have to multiply this 4 times these two terms. That is just the distributive property. 4 times 7 is 28. This would be a negative 4 square roots of 14. On the bottom, we FOIL. 7 times 7 is 49. Outers would be a negative 7 square roots of 14. Inners is going to be a positive 7 square roots of 14. And then last will be a positive times a negative. That's a negative. That's going to be square root of 14 squared, which is 196. But really, I would just know, hey, that's 14. The other good thing is that these inner terms will cancel out because they're the same thing but a plus and a minus. So really, I have 28 minus 4 square roots of 14 over 49 minus 14. Let me write that again. 49 minus 14 would be 35. And then you're seeing if you can simplify. If we can't divide a common factor out of all three terms, then we can't at all. So what's happening is we're trying to simplify 28 over 35. And also 4 over 35. So you're looking at all these numbers that aren't a radical. Do they have a common factor? No. 28 and 35 could be divided by 7, but 4 can't. So we have to say that this problem is finished. All right, number 2. See how we have this radical in the denominator. To get rid of it, we're going to multiply by the conjugate, which means change this middle sign. Doesn't mean to change the negative in front of the 7. So we'll take this times negative 7 plus square root of 13 over negative 7 plus square root of 13. Put parentheses around all your binomials. Negative 6 times negative 7 is 42. And then negative 6 square roots of 13. On the bottom, we'll have negative 7 times negative 7 is 49. I get to where I don't even do the outers and the inners because you'll see you'll get a negative 7 square roots of 13, and then you have a negative times negatives plus 7 square roots of 13. So I don't even do that. I just jump to do the last, which is always going to be a negative because you have a negative times a positive is negative. Square root of 13 squared is just regular old 13. So you can find little tricks to help speed you up. 49 minus 13 would be 36. And so now this problem I do want you to see, is there a common number you could divide out of 42, 6, and 36? Yes, 6. So take each number, divide by 6, divide by 6, divide by 6 in your head. That would be 7 minus a 1, which you don't need in front. So we'll just put square root of 13 over 6. And that would be your answer. Okay, why don't you pause and try number 5. When I FOILed, on the top, this is what I got, 24 minus 6 square roots of 14 minus 4 square roots of 14, and then this became negative times negative is positive, just a regular 14. And then on the bottom, I just did the first terms, And then the last terms, because I know the outers and inners will cancel each other out, and this became just 14. So what I've got right now is 24. Negative 6 minus 4 or more would be negative 10 square roots of 14 plus 14 all over 2. Combine your like terms. 24 plus 14 would be 38. And then you need to see if all three numbers can be divided by something. Yes, you could divide out at 2. So 38 divided by 2 would be 19. 10 divided by 2 is 5. Don't touch the radical. And then 2 divided by 2 is 1. So actually I don't even need a denominator. That would be your answer. Okay, number 6. I see a problem with number 6 because I see the square root of 12 and the square root of 8. They both have a perfect square of 4 in them, so I would reduce them first. Okay, so 12, ooh, can't talk. That would be the square root of 4 times the square root of 3, and 8 is the square root of 4 times the square root of 2. So this would be 2 square roots of 3 minus 2 square roots of 2. This is another one to be fixed. That would be another 2 square roots of 2 minus square root of 3. So you're going to have to multiply by the conjugate, which means change this sign between the terms, which would be 2 square roots of 2 plus square root of 3 over 2 square roots of 2 plus square root of 3. And then you would FOIL top and bottom. So pause that and see what you get. This one's a little harder and trickier to FOIL. Make sure you're multiplying the numbers that are not under the radical, and then you're multiplying the numbers that are under the radical. So you should get a 4 square root of 6. You should get a 2 square root of 9, which is really 3. You should get a negative 4 square root of 4, which is really a 2. And then you should get a negative 2 square roots of 6. On the bottom, you only need to do the first and the last term. So it'd be a 2 times 2 is 4 times a regular 2. Last is a negative, just a regular 3. And so if I clean that up a little bit, I got 4 square roots of 6 minus 8 minus 2 square roots of 6 over 8 minus 3. I'm going to put my like terms together. Let's put the number first, the regular number. Negative 6 minus 8 more would be negative 14. 4 minus 2 would be positive 2 square roots of 6 over 8 minus 3 is 5. I cannot take out a common factor, so that is my answer. So that one was kind of tricky. You might even, I don't know, if you don't like the multiplying like that, you could multiply by the regular conjugate and then simplify your radicals at the end.